Good morning, students. Today let's start off with a theorem, and the theorem here is, if P star is a refinement of P, then L of P comma F comma alpha less than or equal to L of P star comma F comma alpha, that is lower sum of P is less than or equal to lower sum of P star, and U of P star comma F comma alpha less than or equal to U of P comma F comma alpha, that is upper sum of P star is less than or equal to upper sum of P. So that is we need to prove, and here it is understood that F is a bounded function and alpha is monotonically increasing function, and both running from closed interval a comma b to real numbers r. And here P star, since P star is a refinement of P, means it is containing each and every point of P, and in addition to that it is containing some more points. And so according to the definition of refinement, what we'll consider here is P star contains at least one point more than P, because P star is a refinement of P. And let this extra point be X star, and let that X star lie between Xi minus 1 and Xi, where Xi minus 1 and Xi are two consecutive points of P. See here, this is the partition P which we have considered. So P is equal to x0, x1, x2, etc. up to Xi minus 1, Xi, etc. up to Xn. And here P star is containing each and every point of P, and in addition to that we are adding this element X star in between Xi minus 1 and Xi. So your P star now looks like x0, x1, x2, etc. up to Xi minus 1, X star, Xi, etc. up to Xn. So here in P, these two are the consecutive points, Xi minus 1, Xi. But here in P star, these two are not the consecutive points. These two are the consecutive points. These two are the consecutive points. So here we are considering P star like that. Okay, and see here, and next what they are telling, let W1 equal to infimum of f of x. Means they are considering W1 to be the infimum in this particular interval, that is from Xi minus 1 to X star. Okay, and W2 be the infimum of f of x in this particular interval, that is X star to Xi. See, and the remaining infimum will be same as that we considered in P. See here, I will tell you. In the partition P, your subintervals will be like this: x0, x1, x1, x2, and etc. up to Xi minus 1, Xi, etc. up to Xn minus 1, Xn. So these are the subintervals in partition P. In P star, it will be like this: x0, x1, x1, x2, etc. up to, see here, the first interval here will be like this. It is not this now, Xi minus 1, Xi, that is in P. Now it will be, this single subinterval will be split into two subintervals now. So it will be like Xi minus 1, X star, and X star, Xi. So instead of this one subinterval, here in P star we are having two subintervals. Okay, etc. up to Xn minus 1, Xn. So here we are having n subintervals. See here, 1, 2, ith subinterval, and this is n subinterval. So totally you are having n subintervals. But here in P star, you are having n plus 1 subintervals. See, actually instead of this one subinterval, here we are having two subintervals. Remaining all is same. Remaining all subintervals will be same. Only in place of this subinterval we are having two subintervals here. That's it. Okay, and the infimum and supremum of this subinterval will be same as this one. Okay, so there will be no change. Infimum here, infimum and supremum here will be same as infimum and supremum for this interval. And similarly, infimum and supremum of this interval will be same as this interval because there is no change. It is same. But here it will be changed. See here. Here we are having mi, small mi and capital Mi as the infimum and supremum of this particular subinterval. But here we have split this interval into two. So now we don't have this to be the infimum and supremum of this or this. So we are taking the new infimum and supremum for this interval as well as this interval. Okay. So here let W1 be the infimum of f of x in this particular interval, that is xi minus 1 comma x star. And here W2 be the infimum of f of x in this particular interval, that is x star comma xi. So clearly W1 and W2 is greater than or equal to mi. See here, this is the interval xi minus 1 comma xi. Okay, this is the interval in P. And here mi is the infimum for this interval. And here this interval is split into two intervals, that is xi minus 1 comma x star and x star comma xi. Obviously this infimum of this interval will be greater than or equal to this one. And similarly, this may be at last equal to this. So I have used both inequality. What is that? Greater than and equal to. I have used inequality also and equality also. So here clearly W1 and W2 is greater than or equal to this small mi. Okay, W1 and W2 greater than or equal to the small mi, where mi is the infimum of f of x in this interval xi minus 1 comma xi. Okay, closed interval xi minus 1 comma xi. So now actually we need to prove that L of p comma f comma alpha less than or equal to L of p star comma f comma alpha. That is, we need to prove that either this is less than this or this is greater than this. This is greater than this, or the difference between this and this is greater than or equal to 0. Okay, so I am considering the difference now. So consider L of p star comma f comma alpha minus L of p comma f comma alpha. And see here, I have written W1 into alpha of x star minus alpha xi minus 1. See here, actually the definition of L of p comma f comma alpha is summation. See here, L of p comma f comma alpha is equal to summation mi alpha xi minus alpha xi minus 1. So this is for I equal to 1 to n. So this is your L of p comma f comma alpha. See here, I have written only W1 into this plus W2 into this and minus mi into this. Why? Because remaining terms will get cancelled with these terms. See here, we are having the same interval, same subintervals as L of p comma f comma alpha has. Okay, so we'll be having that same mi's into alpha xi's minus alpha xi minus 1's. So here, see, if you understand this, if I expand the summation, you will get like m1 into alpha x1 minus alpha x0 plus m2 into alpha x2 minus alpha x1 plus etc. up to mi into alpha xi minus alpha xi minus 1. plus etc. up to mn into alpha xn minus 1. Okay, so this is what you get for L of p comma f comma alpha. And for L of p star comma f comma alpha also you'll get the same thing, but instead of this you will get two terms. Why? Because you have split this interval into two intervals, so remaining all will be same. So here also remaining all terms will be the same, only instead of this you will get two terms. That is, see here I have considered W1 to be the infimum of this particular interval and W2 to be the infimum of this particular interval. So here instead of mi into alpha xi minus alpha xi minus 1, I'll be getting W1 into alpha x star minus alpha xi minus 1 plus W2 into alpha xi minus alpha x star. Okay, so this is what you will get for L of p star comma f comma alpha in addition to the remaining terms. Okay, so here when you subtract these two, these terms will get cancelled. Okay, except this W1, W2 and mi term, remaining terms will get cancelled. Okay, so here at last you will be left with W1 into alpha x star minus alpha xi minus 1 plus W2 into alpha xi minus alpha x star minus mi into alpha xi minus alpha xi minus 1. So this is what you will be left with after all cancellation of all terms. Okay, so here what I have done is I have added and subtracted the term alpha x star here in this bracket. Okay, I have added alpha x star and I have subtracted alpha x star, and after doing that what I will do, I will combine this plus alpha x star with this term. So it will be like this, alpha of x star minus alpha of xi minus 1, and I will combine that minus alpha x star with this term. So it will look like alpha xi minus alpha x star. So when you take this common, this term common, you will be left with W1 minus mi with this term plus W2 minus mi with this term. And obviously this term is greater than or equal to 0 because, see, since alpha is monotonically increasing, this terms will be greater than or equal to 0. See, this term will be greater than or equal to 0. And coming to this one, W1 minus mi, see here I have already told you W1 greater than or equal to mi and W2 greater than or equal to mi. Means both W1 and W2 are greater than or equal to mi. So obviously this term is also greater than or equal to 0. So complete this RHS is greater than or equal to 0. It means this L of p star comma f comma alpha minus L of p comma f comma alpha is greater than or equal to 0. Okay, so that implies L of p comma f comma alpha less than or equal to L of p star comma f comma alpha. And similarly we'll do for this also. Which one? U of p star comma f comma alpha less than or equal to u of p comma f comma alpha. See here, as we consider W1 and W2 to be the infimum of that intervals xi minus 1 comma x star and x star comma xi, similarly we are considering y1 and y2 to be the supremums of those particular intervals. See here I am considering y1 to be the supremum of f of x in this particular interval and y2 to be the supremum of f of x in this particular interval. So clearly this mi will be greater than or equal to y1 and mi will be greater than or equal to y2 because, why this? Because this mi is the supremum of f of x in this particular interval. Okay, so obviously that will be greater than or equal to y1 and y2. Okay, now consider u of p comma f comma alpha minus u of p star comma f comma alpha. Why? Because we'll show that this is greater than 0. If I prove that this term is greater than 0, then I have proved that u of p star comma f comma alpha less than or equal to u of p comma f comma alpha. Okay, so now I'll consider this, and similarly as we did in L of p star minus L of p, we'll continue the same thing. Okay, so mi, see here, u of p comma f comma alpha is the first term, but here L of p star comma f comma alpha was the first term and L of p comma alpha was the second term. So this mi came at last. Okay, and this w1 w2 came at first because of this. Okay, but what we are doing here is we are considering u of p comma f comma alpha minus u of p star comma f comma alpha. So since we have considered this first, this mi will be first now. Okay, minus then this one y1 of alpha star minus alpha xi minus 1 plus y2 into alpha xi minus alpha x star. Okay, and remaining terms will get cancelled. Okay, as we did previously, and that is equal to, here also I'll do the same thing. I will add and subtract alpha of x star. Okay, and I will take common mi minus y1 as common for this term and mi minus y2 for I will get this as common for this term. Okay, and these terms are greater than or equal to 0. Why? Because this is again because of monotonically increasing property, this term and this term is greater than 0. Okay, and this is also greater than or equal to 0 because mi is greater than or equal to y1 as well as mi is greater than or equal to y2, because we have written that. See here, we have this. Okay, mi greater than or equal to y1 and mi greater than or equal to y2. I am using this. Okay, and here at last we will write this whole term is greater than or equal to 0. And finally, this u of p star comma f comma alpha will be less than or equal to u of p comma f comma alpha because the difference is greater than or equal to 0. And at last we'll get this proof. Okay, so this is all about the proof. Thank you.